Okay, so you're about to watch a video where Professor Trevino shows you how to algebraically find the x-intercepts of a rational function. And she doesn't really talk about why she's telling you to do what she's doing, so I wanted to throw a real quick why in there. So first of all, remember an x-intercept can also be called a zero or a root or a solution. We talked about that, I believe, on this assignment right here where, I have them listed. We've talked about them in other families of functions. They are often used words that are interchangeable. This one right here, you can see graphically that anytime we're looking for an x-intercept, we know that the y value of my x-intercept is always going to be 0 because I'm talking about a point that's located on the x-axis. So what you do, what she's going to tell you to do is set the numerator equal to 0. So I just want to explain to you real quick why you're going to do that. So when you're trying to find an x-intercept, you plug in 0 for y. That should make sense because all x-intercepts have a y value that's 0. So when you plug in 0 for y, right there, you literally put a 0 in the place of y, and then you solve for x. Well, the process of solving for x that you're going to go through right here, since this is a division problem, we have 1 minus x divided by x. Let's undo this division problem and multiply both sides by x. Well, what happens every time you multiply any number times 0? So whatever this denominator is, when we multiply both sides by 0 by whatever the denominator is, it's still going to be 0. So you always are going to end up with, because this is going to be your step, plug in 0 for y, and then it's going to be to multiply to get rid of your denominator. You're going to end up with 0. So skip all of that and just go directly to set the numerator equal to 0 and then solve for x. So here you would subtract 1 from both sides. You would subtract 1 from both sides, and you'd have -1 is equal to negative x. Divide both sides by -1, and you would end up algebraically with the x-intercept is at 1, just like we saw when we traced this. The x-intercept is at 1. Almost the exact same way, if you're looking for a y-intercept, we know the y-intercept is going to be where your graph crosses the y-axis. We know if it's a point on the y-axis, then it's going to have an x value of 0. So if you're looking for a y-intercept, we're going to do the same thing but the opposite. Since it's a y-intercept, we're going to plug in 0 for x. So you take your equation and you literally plug 0 in for x. So the y value for the y-intercept is going to be 1 minus 0 over 0 minus 2. And then you simplify, you end up with -1/2. And yes, you'll do that every time. I believe in her video, Professor Trevino says pay attention to your constants, and that's going to be what your y-intercept is. So if I were working this problem, I wouldn't necessarily need to do this step right here, because I know that the constant of the numerator is a 1, the constant of the denominator is a -2, everything else is going to be a 0. So you pay attention to your constants, and that's where your y-intercept is going to be.